Welcome to this podcast on data and information management. This will involve a discussion about questions related to databases, managing data, and working with information in the computer fields. These topics are from question 4 of the 2024 Information Technology or IT November Theory exam. There are 3 ways that you can engage with the content of this podcast. If you want to test your knowledge, then download the questions covered in the video by clicking on a link in the video description which will take you to a PDF with those questions. And then attempt those questions next. And then once you are done, you can come back and listen to the podcast and compare your answers with the answers that you got. If you want to use the podcast to learn new information, then listen to the discussion and then download those questions that we mentioned earlier. And then try to test yourself to see how well you know the answers from the discussion. Or you can simply enjoy the discussion and learn more about data and information management. Now let's hear what our podcasters have to say about this topic of data and information. Welcome to this podcast on data and information management, and we're going to be going through a couple of questions that revolve around how data is stored and worked with, particularly about databases and data integrity. We're also going to look at some online forms, metadata, and the difference between decision support systems and expert systems. So let's start with our first question, which is a school is organizing a marathon and the entries for all the athletes are saved in a table called TBL athletes. Now, the first thing I want you to know is give 2 reasons why it would be more suitable to use a Google form rather than a printed entry form to register the athletes for the marathon. Now, using an online form has a lot of benefits, and this includes just getting the form to the people that need to fill it out. If you have a paper form, then they have to physically come fetch the form or have a place where they can collect it, where with an electronic online one, you can send it to them, they can fill it out at their own leisure and do it in their own time. And if you've got a physical form, you're probably going to have to take that information and record it into a database or system anyway. So by doing it electronically, you can probably extract that data a lot easily without having to worry about data capturing. And the other benefit about that is with data capturing, you add in an extra person who has to interpret those forms and convert that information into whatever system you are using. So there's probably going to be less mistakes if you just let people fill it in electronically and then you just extract that data. It's also easier to do statistics and reports using that information. And the other key thing is that it's going to be a lot more environmentally friendly. Sending forms means we don't have to print as much. We don't have to store all this paperwork, for example, so it'll be a less of an impact on the environment. So there are lots of reasons why you would want to use an online form than printed entry forms. So let's go look at this actual table that they talk about. So here's an extract of the data from the marathon, where we've got about 12,500 athletes. And they ask us a couple of questions revolving around how this data is stored. And the first thing they're asking us is, we want to sort the information according to the user's surnames. And this is not going to be very easy using this current design. And tell us why this is a problem. What's wrong with this current design? Now, there you can see the name and surname field, and that is very difficult to sort by just the surname because the surname is the second word in most of those fields. It's not guaranteed. What happens if someone types in their first name and second name and then their surname? So do you know that the text after the space is actually their surname? This is very difficult to query. So a far better solution would be to separate the name and surname fields into 2 separate fields, one for name, one for surname. Then you can just do a query or a sort on just the surname field, and that'll make your life a lot easier. It'll be less calculations, a lot easier to query. So now let's look at the cell phone number. There you can see cell phone numbers normally start with a leading 0, but this is being left out, and suggest what we can do to change this. Well, that's obviously because that cell phone number has been stored as a number field. It would be far better to store it as a text or string type. If we make it a string type, then that 0 will stay there because it'll treat it as text. And then we can actually get the correct cell phone number. If you think about it, there are lots of reasons why you would want cell phone number to rather be a text field, besides the fact that the leading 0 will stay if we make it a text field. But there could also be other things. For example, there could be international format. So you want like a +27 in front, and you want to keep that +27 there. And the other reason is you're never going to do number calculations on cell phone numbers. You're never going to take all the cell phone numbers and find the average or add 3 to a cell phone number. So there's no need to calculate it as a number, so we can leave it as text. So now let's look at our next question, where we talk about redundant information, or a field that we don't really need. A redundant field is normally a field that we don't need because we can probably get that information from somewhere else in the database table. And so look in there, athlete number, that seems fine, name and surname we need, email address. There's nothing in the email address that gives me all of the information of their name and surname. So I would rather keep the email address. Cell phone number, nope. Marathon type, nope. So it's probably going to be the race time and the position. So if you've got the race time and we know that the smallest time is the best time, then we actually don't need the position. We can probably calculate the position based on the race time. So I would say that the position field is definitely redundant in this case. I would rather have race time. It gives me more information and we can calculate the position. Then let's talk about two fields from the table that can be used to identify the winner of a half marathon. Now, the two most obvious ones, now we've got position, so I'm going to use that as my answer, but we can use position, which is the easiest one. But if we didn't have the position, as I said earlier, you can use the race time instead. But we need the marathon type because we need to know if it's a half marathon, and we need to know either the position or the race time. And we could do a query like this. We could say where the marathon type equals half marathon and where position equals 1. That would tell us who the winner is. Or we could do, for example, marathon type is half marathon, and then we sort the race time, and then whichever race time is the smallest number would obviously be our first position or our winner. So those would be the fields I use in a query to find the winner of a half marathon. Now let's go to our next question where we have characteristics of quality data or accuracy and consistency. So define the term accuracy and give an example using the race time. Well, accuracy means we need the information to be precise. It needs to be exact. And in this case, we can see that that information is down to the split seconds. So we can see the difference between someone who finished in 205.55 compared to 205.98. The more precise, the more accurate we can have our information. And then the next thing we're going to talk about the consistency, referring to athlete number or athlete num. Now there's a constant format there for the athlete number that always starts with an A followed by 3 digits. And if we want consistency, well, we want to make sure that it follows that consistent trend. It always starts with an A. The moment it doesn't do that, then it's not consistent. Then it's going to be less easy to do calculations on it if we need to. So try to keep your information in the same format. It mustn't contradict or differ from other parts. It would be very weird if one athlete has an athlete num of C3 because that doesn't fit the format of the rest of the athlete numbers. So you want to have a good format that's consistent and applied throughout the database. So we finished with that table. We're now going to look at data integrity, and that's very common with database design and operations. And we want to talk about what is physical data integrity. How do we physically secure the data? And the two main things when it comes to physically protecting data or making sure that the data integrity is solid is normally from, for example, threats like power surges or being damaged or being stolen like physical access. So when it comes to physical data integrity, this refers to guarding against things like power failures, natural disasters, and protecting it from theft, the physical theft of the hardware. You could also mention like the protection of the data accuracy and completeness while it is stored or retrieved or transmitted. So for example, if you're sending data across a cable, making sure that that cable is secure and not interfered with. So that is the physical integrity that we want to protect of the data. Now we want to give two hardware devices that can be used to ensure physical integrity of the data. Hardware means a physical thing. We're not talking about logins or passwords. We're not talking about software. We're talking about hardware. Now when it comes to, for example, power failures, you want to look at, for example, a UPS. You want to look at maybe an inverter or battery, something like that, something that protects your devices against power surges. Those would be physical devices that can protect from power failures. When it comes to access control, maybe you want to prevent it from being stolen. You maybe want, for example, biometric devices, access controls, security doors, or locks. Those would be ways that you can protect the data physically from people accessing it. And then what happens if something goes wrong and you don't want to lose your data? Well, then you need, like, for example, backup. So you would maybe need an external storage device or maybe some RAID technology, redundant array of independent disks, ways of duplicating the data so that if something goes wrong with one part, you've still got backups or extra versions of that data. Now let's talk about the following definitions. We need to give a term for the following. What is the process of refining the structure of a database to minimize redundancy and improve integrity? That's a straightforward definition. That is the process where we normalize or normalization. And then a field containing unique values that could be used as a primary key, but is not currently set as a primary key. So it's a possible primary key, but it's not. In that case, we call that an alternative key. If we need to, we could always make that a primary key, but it's not at the moment. And now we're going to talk about metadata. Metadata is information about the data. So we're going to explain how this adds value. Now, information about the data tells me lots of things. It tells me, for example, additional information about how to interpret or find the information. It might tell me who created that information or where it comes from. It helps to identify and preserve the resources. It helps us to understand the purpose of the characteristics of the data. If you, for example, have a website, you might have metadata which is used for search engine optimization. Information that can be used by Google, for example, to see where it must rank that website. In a photo, you might have metadata which tells you extra information like where that photo was taken, like a geotag. In a document, in a report, you might have, for example, a citation which refers to where that information came from. So that's data about that data. And then we want to talk about expert systems and decision support systems. Justify the use of an expert system rather than a decision support system in knowledge-intensive organization. And the key word there is knowledge. We want to refer to the knowledge. Now, with a decision support system, that normally just gives us information that can help us to make a decision. It does not actually give us the solution, but just gives us information to make better decisions. But when it comes to knowledge, we want the best knowledge of the people involved or based on the experts. And so that's where an expert system will be far beneficial because it provides the fixed number of possible solutions gathered from experts in that field. If you are referring to a particular knowledge intensive field, you want the experts of that knowledge. If this was a medical system, you want the expert system to have the knowledge of medical doctors to be able to make the best decision. If you had a system that was guiding a plane, for example, you would want the best experts to give their knowledge to the system to make the best decisions when flying that plane. So that an expert system would be beneficial over a decision support system. And now to our last question. We're going to talk about a digital footprint that's created using invisible data collection. Give 2 examples of where a digital footprint can be used. Well, they're good and bad ways to use a digital footprint. And a good way, for example, is companies use that information about you. They find out where you've been or what companies you might have worked for. Or, for example, things that you've said online that might influence if they're going to hire you or not. So a lot of these companies like social media and that, they actually collect data about you, and that's your digital footprint, all the things that you like, all the things that you are interacting with, and that information can actually be sold to other companies and they can use that for advertising. So if you're someone who interacts with a lot of, for example, coffee adverts or speak about getting a coffee every morning, then if they sell that information to advertisers, then a coffee company might target you a bit more than someone else because they know that you enjoy coffee. Now, the disadvantage as well is that cyber criminals can actually use this information. They can see things that you are interested in and maybe create an online fake identity of you and use that for identity theft or for phishing attacks, trying to manipulate you into clicking on websites. They could do that. And then you are aware of context-aware searches that use other information to give you the best search results. So if they see what other things you've been interacting with online or what you've searched for, then the searches that they provide, the results for that search, could be skewed according to whatever you've interacted with recently. So all of those are ways that you could use a digital footprint. We've covered quite a bit of information about data information. Hopefully it's been useful. The link to the questions is in the video description, which you can also use if you want to go through those questions again and see how much you remember. So hopefully you've enjoyed this session on data information management. And now let's move on to our next podcast. It would really help the channel if you click on the subscribe button and share us with other people. Don't forget about our other channel at Mr. Long IT and Cat for other information about databases, for example. And remember, don't do it the long way, do it the Mr. Long way.